This was the hardest question on the Intermediate Maths Challenge 2026 paper. It's question 24, and what it's asking you to find is this little area up here. So you can see we've got an irregular quadrilateral been split into 4 parts. We've been told the area of 3 of those parts, and it's asked us to find the remaining one. The only information that we know at the moment is that K, L, M, and N, these are all midpoints of each side of the larger quadrilateral. So we can see that these are the same length. How can we start this? It's not obvious at all, because is there a formula for the area of an irregular quadrilateral? If we could just find the area of the full thing, we could just take away these 3 and that would be fine. But it's not going to work here. So what can we do instead? Well, we've got this T in the middle, and the T could be anywhere, and we can see how that would change the area of the 4 parts of this quadrilateral. That was something I was starting to think about and kind of play with. And then the other thing is, we know these lines, each side of the larger quadrilateral is just divided into 2 equal parts. If we can learn how to use that piece of information and how it relates to the areas of each part, that's going to be the key here. It's not obvious what we can do. Joining up this point T in the center with each of the vertices of the quadrilateral. And I noticed that gave us a lot of triangles. When I was looking at this, I spotted, and that's if you have 2 triangles, they've got the same base, and these lines are parallel, so they have the same perpendicular height. And because the area of a triangle is half the base times the perpendicular height, they must have the same area. And what's interesting is that actually applies here. If we look at base being Q to L for this triangle QLT, then because it has the same base, and we could draw a line that is parallel to QR, it must also have the same perpendicular height and base as the triangle LRT. Do you see it? Now, because these triangles must both have the same area, we could label that area just with an A, for example. And we can use that same logic every other pair of triangles around the quadrilateral. So these we could label both with a B, these with a C, oh, they were already labeled, and finally these with a D. Now we're making progress, because now we've got that 20 is A plus D. So 20 is A plus D. We also know that 24 is A plus B, and 15 is B plus C. And we're looking for X, which in our A's, B's, C's, and D's is just C plus D. So C plus D is equal to X. So we want to rearrange these equations to find C plus D. So we can go ahead and do that. And I think just by looking at it, if we add the first and the third equations together, we're going to get 35 is equal to A plus B plus C plus D. And then if we subtract the second equation from that, the 24 equals A plus B, we're going to get our C plus D here. So we subtract 24, which is going to give us 11, which is C plus D. And that is the area that we're looking for, X.